Assalamu alaikum, my dear student. Today our topic is continuous charge distribution. Continuous charge distribution. Charge means charges are intrinsic properties of fundamental particles. Two type of charges, positive and negative. But here our topic only discuss continuous charge distributions. Means the continuous charge distribution is a system in which the charge is uniformly distributed over the conductors. Mean the charge is uniformly distributed over the conductors or lines or surface or volumes in any field. Means continuous in any field may be surface, lines or volume, but in continuous. Our topic also is our continuous charge distributions. In continuous charge systems, infinite number of charge are closely packed. Mean infinite number of charge we count in continuous charge distributions. Here we discuss the charge is distributed continuously over some regions. The sum become an integrals. Means if we count the continuous charge distributions by integrals, means integral is a sum of all charges. Okay, for example, this is a surface and dq is denoted by continuous charge distributions to at point p. R is a separated distance between them. We only count electric field for continuous charge distributions. What is electric field? We know that the electric field or electric intensity is equal to F over Q naught. And we know that what is the force? Force is the electrostatic force, or Coulomb force is equal to 1 over 4 pi epsilon naught Q naught over R squares. Using value here, then we obtains charge electric field for one charge. Electric field for one charge. Okay. Is equal to 1 over 4 pi epsilon naught Q over R square. This is electric field for single charges. But we considered electric field for continuous charges. For continuous charges we considered q dq and use integrals. For continuous charges we use integrals. This is a continuous charge distributions. We count here's electric field. This is the electric field for continuous charge distribution, and this is electric field for one charge, and this is electric field for continuous charge distributions. And now we discuss the point in which the charge is continuously. For example, line charges, the charge is distributed on lines, and also charge distributed on surface, and also distributed on volumes, and affect the electric field when charge distributed on line charges. For examples, if the charge is spread out along a lines, then we define line charge density. Line charge density denoted by lambda is equal to charge per unit volume. For example, this is a lines. The total length of line is L, and charge is Q. But we considered continuous charge distribution, means denoted by dq, and also total length of L. But if we count length for distribution charges, and also we divide length in small patches, for example dl, and we know that the line charge density is equal to charge per unit length. Lambda is equal to charge. For example, this is charge over length. But we considered continuous charge distribution, then we use dq and dl. This is for single charge electric line charge density, and this is line charge density for continuous charge distributions. dq is equal to then multiply here is equal to lambda dl. This value we use here equation 1. Equations 1 becomes E is equal to 1 over 4 pi epsilon naught lambda dl over r squares. Mean lambda is a constant. We write out from integrations. Integrate only length. Okay. Integrate only length. This is dl. Means total length is l, and we only use length for small for continuous charge distribution, and only we use small patches of length. We also measures lambda, means lambda also known as linear charge density. We measure linear charge density. Lambda measure in q, mean unit of q is coulomb and length is meters. Also measure in lambda in coulomb over meters. Coulomb over meters. Coulomb over meters. Coulomb over meter. Understand? Now, electric field for surface charge distribution. For surface charge distributions, we already count electric field for line charge distribution, but here we consider surface charge distributions. If the charge is spread out over a surface, then we define surface charge density is equal to charge per unit area. Surface charge density also denoted by sigma. And for examples, this is a surface at point P, and here is dA. D mean area. R is a separated distance between them. The surface charge density denoted by sigma is equal to charge per unit area. This is a surface charge density for single charges, for single charge, but we consider for a continuous charge distribution. Then sigma is equal to, for continuous charge distribution, dq over dA. This is continuous charge distributions. Okay, and dq is equal to sigma dA, putting in 1, then is E is equal to 1 over 4 pi epsilon naught sigma dA over r squares. And we measure, how we measure sigma? Sigma measure in q, unit of q is coulomb and unit of A is meter cubes. Sigma measure in coulomb over meter cubes. And also we count electric field for volume charge distributions. Volume charge distribution, the electric field for volume charge distributions. If the charge fill a volume, then we define volume charge density is equal to a charge per unit volume. We denote volume charge density by rho. Okay, and volumes, for examples, this is a volumes we use at point P. At point P, R is a separated distance. This is volumes. We also write V in tau forms, but here we use this form. Okay, understand, not confuse. Volume charge density rho is equal to charge per unit volume. this is charge over volumes. Okay, for single charges. And we count for continuous charge distribution. This is equal to dq over dv. This is continuous distributions. And then q is equal to sigma over rho dv. Put in 1. Then E is equal to 1 over 4 pi epsilon naught sigma dv over r squares. Understand? And rho measure in the unit of q is coulombs and volume meter cubes. Okay, understand? Means we convert charges for, understand from here, we convert charge distributions for line charges is equal to lambda dl, and for surface charge distributions we convert charge into sigma dA, and for volume charge distribution we convert dq into rho dv. This is our relations for better understanding. Okay, for line charges we convert charge distribution into lambda dl. For surface charge we convert into sigma dA, and for volumes distributions convert into rho dv. Okay, clears?